Hey gentlemen, good morning all of you. So in this module we are going to discuss about currents. Electric current is the rate of flow of charge. So the charges are flowing through a conductor and at what rate they are flowing, how many electrons are at motion, right? So they basically will make up the current. So we can say that electric current is nothing but charge flowing through the conductor per unit time. So let's say this is a conductor and let's say it's electrical wire, it's a conductor and it's made of atoms, and furthermore atoms can be divided into protons, electrons and neutrons. And as we know that protons and neutrons, they are at center of an atom, basically nucleus, and they don't move. So it's the electron that are in motion. So electrons are traveling in the wire. Normally when the wire is just kept like this, then the motion of electron is random. They can go in either directions, zigzag motion, something like that. But when this wire is subjected to an electric field.
Hi ETO aspirants, Jai Hind, Jai Bharat, Jai Mata Di. I hope you like this video. Always aim for joining top-notch companies with top-notch sponsorship in shortest time possible, because time is money and time is never going to come back. I have got two solutions for you. One is ETO Aspirant Express Package on Merchant Navy Decoded platform. Online courses, watch at the comfort of your home. Second is 100% results, faster results. Come to SMVD Marine Academy offline coaching. Jai Hind, Jai Bharat, Jai Mata Di. Choice is yours. Link is in description box.
Or let's say I connect a battery across the terminals of this wire, then these electrons are forced to move in certain direction, right? And when they start to flow, they will constitute what we call as current. So current is nothing but a flow. Just like in a pipeline the water is flowing, we call that as a water current. So same way here it's an electric current, right? Okay. And the SI unit is ampere. So current is measured when we say it's a 5 amps current or 10 amps current. And this is, let's say 1 amps is nothing but 1 coulomb of charge flowing through a cross section perpendicularly in 1 second. So if I take a wire and if I take one cross section of the wire and if I see perpendicular to that cross section how much current is flowing, how much charges are flowing, 1 coulomb of charge, if it has flown through the cross section in 1 second, I can say that this is having 1 amps of a current, right? For example, in your air conditioning system in your house, normally let's say it is 1.5 tons of a AC, running current normally is around 6-7 amps. So we can say that, let's say 6 amps, so that means 6 coulombs of charge is flowing through the wire in 1 second. So that's the concept of a current, right? Okay, so we can see that we can divide it into instantaneous value where it is dq by dt, or an average value delta q by delta t. So I hope the definition is clear, the units are clear. Let's move ahead. Now the question arises, which way does the current move? And why I'm saying this? Because sometimes we see this problem that we normally talk about electron is flowing, but when we start discussing the direction of flow of current, we show it reverse. For example, you can see that this is a battery, positive terminal, negative terminal. This is a load, which is in this case is a lamp. So we normally show the direction of current in this direction. That means from positive to negative. It sounds wrong, isn't it? Because we know that it's the electron that flows and they come out of negative terminal, not the positive one. So ideally it should have been this direction. But then why are we taking, normally when we talk about the current flow, we talk about this. And this should have been this. So where does the problem lie? Let's see. So let's go back and see the reason. Now the reason lies in history. Historically, because when the electricity was discovered, this was way long back. It was way long back in 1752. Credit goes to Mr. Benjamin Franklin. So people knew what electric current was in 1800s. We knew that. However, we didn't know about electron till 1897. We didn't know what electron is, where it is lying. Is it the electron that flows or is it the proton that flows? We didn't know that. So initially they understood that there is some charge that is flowing. They considered that to be a positive charge. It is later on we came to know that it's not the positive that flows, it's the negative. It's the electron, because positive can't move in the solids. In the solids, atoms don't move, so proton don't move. It's the electron that moves. So this was a historical mistake, but we are carrying on with that because it's not making any changes in the calculation part. All what changes is just a sign. So instead of plus, we can just take minus. That's it. Everything remains the same. So much of books have been written on this thing. So much of research was done after that, after this year. So it was very difficult to change all the materials at the same time. So they just went on with the same terminology or same analogy. Just that now we start to call this direction, this flow we'll be calling as electron flow. However, this one we'll be calling as current flow, or to be more specific, to be more precise, conventional current flow. So when we say current, we are talking about conventional current until and unless someone specifically tell you electron flow direction, right? So we'll be considering as if something positive is flowing in the system, right? So we just imagine some positive thing is flowing from a positive terminal to the negative terminal. So I hope that point is clear. Okay, so that's all for in this section. We'll move on and we'll discuss about resistance in the next module.